Hi guys, welcome to the next part of power electronic circuits. So we have started dealing with the choppers. Already we have been solved so many questions. So let us continue the lecture. So while solving the problems, whatever the instruction that I told you, just follow it. There is no any instruction, just be calm and be conscious. Keep smile in your face. Try to solve the problems in active mode. Okay, okay. So let us go ahead with the first question. I hope I had given this question as the homework one. I don't know how many of you did this. If you already did this question, drop your answer in the comment section. If you not did, take 2 minutes, try and solve it. Again, I'm expecting your answer in the comment section. You can take 2 minutes for this question. Try to bring the answer. If you already got the answer, you can drop it in the comment section. Otherwise, just do it. Okay. Kanaga Savita, 31.25 millihenry. Very good. Any other answer? Is there anyone that is? No. Chalo. See, it's a direct question. Already we have been solved in this type of model. We have been solved already. And what is this question? The question is, sir, a chopper circuit is shown in figure. Yes, there is a circuit. It's a chopper circuit. And its resistance is 0.5 ohm. They told that the output resistance is 0.5 ohm. Supply voltage Vs is given as 500 volt. Yes, okay. Battery voltage, they told that this is short circuited one. Why, sir? Why short circuited? It is zero voltage, right? Zero voltage means it is short circuit only, na? Good. Then average load current, the current flowing through the load and the average current. So this is given as 100 ampere. Frequency of this circuit is given as 200 Hz. Under this situation, what is the value of inductance that will let the maximum ripple current through the load will become 20% of the actual load current? We have to find out the sufficient value of inductor in order to make the maximum ripple current as 20% of the load current. Sir, as I already told you the relation, anyway, what is the generalized formula to obtain the ripple current through the inductor or load? Here both are connected in series only. Of course, we know it's buck converter. So del IL, it can be generally written as del into 1 minus del into supply voltage Vs divided by L into F. This is normal ripple current. Yes, sir. Inductor ripple current or load current. Load ripple current. Now the question is, what is the value of del IL maximum? We know del IL will become del IL maximum at the value of delta equal to 1 by 2. I had given proof in the last class. I hope you all have remember it. So what we found is at a delta equal to 1 by 2 we got del IL will become del IL maximum, and we saw the formula also. Del IL maximum can be written as, if I will replace del by 1 by 2, see there 1 minus 1 by 2 will become 1 by 2. Here also 1 by 2, 1 by 2 into 1 by 2 will become 1 by 4. So it will be Vs divided by 4 times of L into F. This is the formula to obtain the maximum ripple current. Now they already told that this maximum ripple current del IL maximum is equal to 20 percentage of load current, actual load current. So I can write 20 percentage means 20 into what is the value of load current? Value of the load current is given as 100 ampere. If you observe the question, it will be clearly visible that 100 ampere divided by percentage, it is in percentage. So I am dividing it by 100 in order to get the actual value. So 100 will get cancelled. 20 percentage of 100 we all know that is 20 ampere only. Yes sir, we got the value of del IL maximum. Now again go to this equation, replace del IL maximum by 100 ampere will be equal to supply voltage is given as 500 voltage divided by 4 times of L is not known, frequency is given as how much frequency? 1 minute. I have to, yeah, it is 200 hertz. Frequency is given as 200 hertz. From this we can say 4 times of 200 will be 800. So the value of, just to pass the L to the right hand side, bring that, sorry, left hand side, bring that 100 to the right hand side such that it can be rewritten as L equal to 500 upon 4 into 200 will be 800, with this one more 100 also coming from the left hand side. Now this 20 will get cancelled out. So we can say 5 upon 8. See, this 100 can be written as 10 power 2. If I will pass it to the numerator, it will become 10 power minus 2. Now slowly cancel it. 0 point, it will become 50 because directly we can't cancel. Then how will you cancel it? First 6 times of 80, right? So if you go with the 6 times of 80, it will become 48 6 eighths. Yes sir, remainder is 2. Again we can say 2 times, again 5. So we got 0.625 into 10 power minus 2, or we can say 6.25 millihenry. So this is the answer that I got. This is how we are calculating the value of inductance. So I hope every one of you got the idea. Sure. Let us go ahead with the next question. Yes. So the next question is, note down, in a chopper circuit shown in the figure, in a chopper circuit shown in figure, in a chopper circuit shown in figure, the input DC voltage has a constant value. See, input supply voltage is constant and output voltage is assumed to be ripple free. They are telling that output voltage is ripple free. Ripple free. The switch S is operated within switching time period T. See, switching time period is T. Fundamental time period to complete one cycle is T. Duty cycle they told delta, del. Now what is the value of delta at the boundary of continuous and DC? Question is, what is the value of delta at the boundary of, it is very important, it is the boundary of continuous and discontinuous inductor current, the boundary of continuous and discontinuous inductor current IL is dash. What is the value? What, sorry, is not required. What is the value of delta at the boundary of continuous and discontinuous inductor current? It's a good question. Whereas the data is given as the value of supply voltage Vs, it is given as 100 voltage, and the value of output voltage, it is given as 80 voltage, comma, the value of load resistance is given as 0.5 ohm, and the value of inductance L is given as 1 millihenry, and the frequency is given as usual 500 Hz. Now the given circuit is, there is one inductor, yes, then there is one diode, here they kept the switch, here they kept the supply voltage Vs, sorry guys, yeah, and here we are going to connect the load, that's all, and here they are going to measure the value of output voltage. This is supply voltage, switch, diode, inductor L. This is the given circuit. Now if you can take your time and try to drop the correct answer for the question. You can take 2 minutes first. Don't think too much. Okay. Guys, one small correction. Take the output voltage is 180, not 80. There's a small mistake. 180 voltage. Sorry. You can carry on. Anyone got the answer? Sorry. No? Take 1 more minute also. No issue. But I need the correct answer. At least just think. Just 0.4 second. 0.4 second. Delta, Rajesh. Value of delta is dash. Okay, is it 0.4 might be, huh? Your answer. Good. Any other? Sure. See, let me try to solve this question. Then nothing is there. What type of circuit it is? You might have understood that. Sir, this is boost converter. This is boost converter. First conclusion. For the boost converter, we know the output voltage V0 equal to supply voltage Vs upon 1 minus delta is the standard formula that we are following. Yes or no? And in the question they told that, see that in a chopper circuit shown in the figure, Vs is constant, output V0 also constant, because ripple free means you know the meaning that is constant. Fundamental time period is T, and delta value, delta we have to identify. Delta, what is the value of delta at the boundary of continuous and discontinuous value of inductor current? Nothing is there, almost it will be considered as continuous only. See there, they are asking you to figure out the boundary. Boundary means just about to crossing zero cross point. Suppose if your inductor is charging, then again it is discharging, again it is charging. So this point is called what? Suppose after this point if inductor is not charging immediately, then for a certain time period current will be zero. But here it is what they told, that it is the boundary of continuous and discontinuous. Boundary of continuous and discontinuous means system will be marginally stable. Almost it is in verge of instability. It will be like this. It is going. It is just crossing the zero crossing point, but it is immediately charging. Again it is discharging, but it is immediately charging. So there will be no gap between the continuity and discontinuity. Almost this will be considered as continuous current only. Okay, sir. And we know the output and the input relation from this. And simply from this, if I will reduce this expression, I can, if you pass 1 minus delta to the right side, sorry, to the left hand side, it can be written as Vs upon V0. So minus delta equal to, just to pass this one to the right side, it will become Vs upon V0 minus 1. Pass this minus also to the right side such that the value of delta will become 1 minus supply voltage Vs upon V0. Now 1 minus supply voltage, it's already clearly given as 100 upon voltage is given as 180. I can cancel 1 0 will be cancelled. 5 times of 2 will be 10. 9 times of 2 will be 18. So I can rewrite this 1 minus 5 upon 9. Sorry, 5 by 9. If I'll take the cross product, it will become 9 minus 5. 9 minus 5 will be 4 by 9. How will you reduce this? So the left delta equal to 0. Point. If I'll keep 1 0, 4 times of 4 will be 36. Again, so delta equal to 0.44. Good. This is the correct answer for the question. Okay, very good. Yes, many of you got the answer. I'm really very happy. Let us go ahead with the next question. 1 minute. So we have solved this. One minute, guys. There is some stuck here. Okay. Now let me bring the next question. What the question is? The output voltage. Okay, they are going to chopper. Fine. Okay. Consider this step down chopper as a shown. Consider the step down chopper. Consider the step down chopper. It is given. shown in the figure. Consider this step down chopper shown in figure. First one. Okay, sir. Now the question is maximum value of current through the capacitor. IC maximum value of current through the capacitor. So I'm going to draw the circuit now. Then here we are going to place the capacitor. Here we are going to place one more thyristor. Here we are going to place diode. It will be in series with an inductor. See, I have reversed the direction of diode. It is wrong. 1 minute, guys. Yes. Actually, here diode must be in this direction. Next, it will be closed like this. After that, it will be connected with a load. Okay. Yes, this is the circuit. Across the load, we have a freewheeling diode also. It is given, and supply voltage here it is given as 150. This capacitor value is 1 microfarad. This is main thyristor. This is auxiliary thyristor, diode D. Inductor value is 1 millihenry. This is load. That's all. Now what I told you, what I asked you, maximum current. Capacitor maximum current is dash. Now you can take your time and try to talk your answer. Do it fast, be conscious, active or in. Do it fast. If you got the answer, immediately drop it in the comment section. Anybody? No one? Okay, fine. I need one. I have a small doubt. What is the name for this circuit? Okay, it is acting as a step down chopper. That is fine. They have given some commutation circuit, right? I hope we have seen variety of commutation techniques. What is the name for this one? Anyone? What type of Rajesh? 4.743 ampere. Very good, Rajesh. Good. I just wanted to know the name of this circuit. What is the name for this circuit? What type of commutation technique people have used here? Anyone? Actually, the question is what is the maximum current that can be flow through the capacitor? Kalaivoni, class D. Class D. What is the name? Is it class D commutation? Class D commutation. Of course, Rajesh, I'm agree with you all. Listen, guys. There will be some name for this commutation. Like we can call it as load commutation, we can call it as current commutation, we can call it as voltage commutation, or we can call it as complementary commutation. Like that, we might have saw some name for this circuit. What is the name? Is it load commutation or it is complementary commutation? Any answer like that? You can drop it if it is there. Now in this case, I just wanted to know the maximum current that can flow through the capacitor, right? Chalo. See, here the maximum current that can flow through the capacitor. For that, we know it will be basically, we had a derivation for everyone. Yes, yes, Rajesh, very good. That is voltage commutation only. So let me bring it. Let us make it everything. Here the current flow through the auxiliary thyristor. First conclusion. Here the question is, first I am asking what is the maximum peak current that can flow through the main thyristor. M denotes main thyristor, P denotes peak current. That is maximum current. Okay, so the maximum current that can flow through the main thyristor is the addition of output current I naught plus maximum peak current flow through the capacitor. That is the first conclusion. Whereas the current through the capacitor IC max can be written as, I will simply write IC max. That's all. That is the maximum current that can flow through the capacitor. So what is the formula? Yes, let me write. The maximum current that can flow through the capacitor is the derivation, right? It's a simple, we all know that is supply voltage Vs into C upon L whole power 1 by 2. That is the maximum current that can flow through the capacitor. Then what is the maximum current that can flow through the main thyristor? Peak current flow through the main thyristor. That can be equal to output current I naught plus maximum current that can flow through the capacitor Vs into C by L whole power 1 by 2. This is the formula for this two. Right, sir. Now, anyway, what is the question? Maximum current that can flow through the capacitor is the question. What is the value of supply voltage? 150. What is the value of capacitor? 1 microfarad. What is the value of inductor? 1 millihenry. Micro means 10 power minus 6. Milli means 10 power minus 3. Whole power 1 by 2. So I can write 150 into, in bracket we have 10 power minus 6 upon 10 power minus 3 whole power 1 by 2. Now if you pass this 10 power minus 3 to the numerator, it will become 10 power plus 3. So 10 power minus 6 into 10 power plus 3 will become 10 power minus 3 whole power 1 by 2. It can be further written as 150 into 10 power minus 3 can be written as 10 power minus 2 into 10 power minus 1 whole power 1 by 2. Now you can take it out. See there. 10 power minus 2 whole power 1 by 2 can be written as, it will come out. It will come out as 0.1. 10 power minus 2 we can directly take outside. Okay, sir. So I can write 150 into 0.1 will be 115. In bracket we have one more 0.1 whole power 1 by 2. Yes, sir. Now, so one more 0.1 whole by 2 means we have to take the 1 minute, guys. Yeah. So take the root for, find the root value of 0.1. If I will find the root for 0.1, we will be getting 0.316. Outside we have 15 into 0.316. So if I will multiply it by 15, we will be getting 4.743 ampere. Very good. Already someone did, right? Is it Rajesh? Yeah, good. So the correct answer is 4.74 ampere, 743 ampere. Suppose if the question is what is the maximum current that can flow through the main thyristor அப்படின்னு கேட்டிருந்தாங்க, they will give you the clue to identify the current flow through the load also. Average load current will be given. The current that can flow through the output is, they might give some 5 ampere, 10 ampere like that. Then you can add these two to know the maximum current that can flow through the thyristor. Here for this voltage commutation circuit, there are so many other things. What is this so many other things, sir? What is the on time of main thyristor? You will be asked to calculate the what is the on time of main thyristor. That formula is pi into square root of L into C. Similarly, they will be asking you to calculate the circuit turn off time of main thyristor. So that can be written as C into supply voltage Vs upon C. I hope these all formulas are available in our notes. Similarly, you'll be asking to calculate the circuit turn-off time of auxiliary thyristor. That will be pi by 2 into square root of L into C. Then you will be requested to calculate the duty cycle for this circuit. Duty cycle is pi into root of LC into F or 1 by 2. Everything is fine. Then the one more important question is V naught average. In voltage commutation, what you have to observe is V naught average. What is the formula? Supply voltage Vs into frequency of, in bracket it is pi into square root of L into C into 2 times of, sorry, it should be plus, not into. It will be 2 times of main thyristor turn off time, circuit turn off time, or we can say C into VDC, VDC or Vs, supply voltage Vs divided by I naught. That's all. Are you getting me? Pi into root LC separate. Then 2 into CVS divided by I naught is separate. You can add both two and then multiply it by supply voltage Vs into F to obtain the V naught average output voltage. Clear? So like this, there are so many formulas in the complementary commutation. Complementary commutation, you can't find any formulas except a turn of time. But current commutation and then load commutation, for the load commutation circuit turn of time is what? Pi by omega d, where yes, omega d equal to omega n into square root of 1 minus epsilon square. Those conditions are very important. And if you observe load commutation, it will be working under commutation. Load commutation usually will be operated under commutation. What is the condition? Epsilon. For the under commutation, the value of epsilon is less than 1, and epsilon can also be written as r by 2 into square root of c by l. என்ன சார் சொல்றீங்க, ஒண்ணுமே புரியல. It all there in our short notes. Okay, you can just go through it once. I might have given it already. Okay, because here we cannot waste our time, because this all things already we were covered. Chalo, let us go ahead with the next question. The next question is, consider the same circuit, same step down chopper. Now what they did is, the operating frequency F, they told that it is 400 Hz. Next question I'm talking, 400 Hz. What is the minimum duty cycle of the circuit? What is the minimum? Take the same circuit, the only thing is frequency is 400 Hz. What is the minimum duty cycle? I hope you understand. They took the same circuit. You can start solve this question. Step down chopper circuit. Last time they have asked maximum current flow through the capacitor. This time they are asking what is the minimum duty cycle when frequency f is equal to 400 Hz. Okay, I had given the answer already just now. See there, duty cycle I wrote pi into root LC into f equal to 400 Hz. Okay, fine. Substitute everything, at least just to drop the answer, but do remember all these things I told now. See there, next question itself we got the question related to that. Just drop your answer. What happened? Why no one dropped your answer? Chalo. See, it's not a big question to solve by my hand. Everything is given. You can just substitute. Frequency is 400. Inductor L equal to 1 millihenry. Capacitor L is 1 microfarad. Pi is 22 by 7. You all know. Just reduce this. You will get the answer for duty cycle delta. Right? So let us go ahead with the next question. Let me bring the next question here. Actually, the question is figure show the circuit. The figure shows chopper circuit where supply voltage Vs is given as 100 voltage and duty ratio delta is given as 0.75 and the value of okay, output current I0 is ripple free. Output current I0 is ripple free. That's all. This is the given data. Now the question is, what is the ratio of average current through the switch and the diode? Ratio of average current through the switch or thyristor and average current through the diode. What is the ratio of the average current through the switch and average current through the diode? Whereas the given circuit is they have taken one switch, they kept the diode here, and here inside directly they kept the load. Here we are going to measure the value of output voltage V naught. Supply voltage equal to, already it is given 100 voltage. Yes, this is the switch. All the data is given. You can start solving this question. Drop your answer in the comment section. Do it fast. Got the answer? No one? It's a simple question. I don't know how many of you are there in live. What? It won't take much time. See, first of all, you can easily identify the type of the given circuit. It's a buck converter. This inductor, usually inductor will be connected in series here. Sir, where is that inductor, you can ask. It might be inside this load. What is there? Inductor is series connected to the DC output. Its behavior you all know. It will not affect your voltage waveform. Then what is the point of bothering about it? You can treat it's a step down converter directly. Okay, sir. When it is a step down converter, what is the question they have asked here? The question is, what is the average current through the diode, ratio between average current through the thyristor and average current through the diode. Okay, sir. Now where is the switch? This is the switch. How will you draw the output waveform first for the current? Let me tell you. I know many of you know it, but I don't know why you haven't given the answer. See, when the moment if first T on period. T on period means we are closing this switch. When the moment you are closing the switch, output current will started flowing through the switch. After that, after T on, switch will be turned off for particular time period. Sometime it will be T off. This is called off time. After that, again on time will come. Once again, same switch will be continuously allowing the current from the supply. Now, this is the current flow through the thyristor. If you observe the current flow through the diode, what will happen? Current will flow through the diode. When it will happen? Through the load, it will be flowing like this. This case will happen when switch will be not be in present. That is when switch will be open. Switch will be open between that is this is off time period of switch. So only in that particular duration, output current will started flowing through the diode. But this current is called generally output current I0. But how it is going? First half it is going through the switch, second half it is going through the diode. Again switch, again diode. This is the continuation. Now that's not a big deal to deals with the value of output current through the thyristor. How will you calculate the average current through the thyristor? You all know the formula is area by time period, sir. Now how will you write down this area? Area means see there on time with height is I0. So it can be written as on time into output current I0 divided by fundamental time period T. We all know on time divided by T is nothing but delta. So delta times of I0. So it is very easy to write down the expression for average current through the thyristor. It is simply delta into I0. I0 can also be written as, it is ripple free. I0 is ripple free. It can't be written. It can also be written as V0 average divided by load. Load is resistance. Right. So this is alternative way to write down this expression. This is how we are writing the expression for average current through the thyristor. Can you please do the same thing for average current through the diode now? For the diode, the current is flowing through the off time period. Off time period means, we know basically I already told you on time, off time is generally always dealing with the switch. Off time is basically telling that the switch is open for some time period. During that time period, the output current started freewheels through the diode. So that is called off time period of the switch. So during the off time period, how can I write the expression for switch? Diode average current then? See, diode average current, as usual, the formula is area by time only, sir, undoubtedly. Area can be written as height into width. What is the width here? Off time period divided by fundamental time period. Yes, sir. Now, I'm just asking you, we know this off time can be replaced by, we know, T is equal to T on plus T off. Yes or no? From this, T off can be written as, if I will pass this T on to the left hand side, T off can be written as T minus T on. I can write T minus T on by T. If you open the bracket further, I0 into T by T will become 1 minus T on by T will become delta. So our average current through the diode can be written as, how will you write down this hereafter? Output current I0 into 1 minus delta. Yes or no? Okay, sir. Output current as usual, it can also be written as V0 by R into 1 minus delta. Now it is time to take the ratio between these two people. First, average current through the switch. Average current through the switch is delta times of V0 by R. Average current through the diode, it is 1 minute 1 minus delta into V0 by R. So V naught by R, V naught by R will get cancelled out. What is value of delta? Is it given in the question? Chopper circuit. Yes, it is 0.75. Good. 0.75 means 3 by 4. Divided by 1 minus 3 by 4 will be equal to 1 by 4. So we can write 3 by 4 divided by 1 by 4. So 1 by 4, 1 by 4 will get cancelled. It will be 3. So what is the conclusion here? For this circuit, the average value of the switching current equal to 3 times of average value of the diode current. That's all. That is the answer. Okay. So the correct answer is 3. I hope you guys understood this question. It's it's really beautiful question, right? I hope if you guys enjoyed, then it is beautiful question only. Same question will get again repeated. 1 minute. I'm trying to bring if there will be any new questions are possible. No, all other questions are same. Chalo. So we were covered almost the basic things, whatever that are required in our chopper circuits, and I have solved so many questions. Nothing is there to understand in chopper circuits. Just I already told you, watch any one chopper circuit properly. If you understand one chopper circuit, how to derive the all formulas like how to calculate the V naught average, I naught average, ripple in inductor current, ripple in capacitor voltage, critical inductance, critical capacitance, then what is the V naught average when the circuit is discontinuous, when the circuit will have discontinuous conduction. If you just do remember these basic things, you will be able to play with all type of circuits. It doesn't matter what type of circuits they are giving. Okay, sometimes it is better to keep by heart something in your mind. That's also will be useful. See, when the moment you are going from continuous conduction to discontinuous conduction, what I told you, how to write the expression for V naught average. See, the most of the time they will be asking you to calculate the V naught average only. For the discontinuous conduction, what you have to do is just replace wherever you have delta, replace delta by beta, such that, see, if I write the expression for buck converter, we all know it can be written as delta into output voltage, delta into supply voltage Vs. This is for discontinuous conduction. Whereas for the discontinuous conduction, delta should be replaced by delta by beta, right? So delta by beta into supply voltage Vs. Similarly, for the boost converter, we know it can be written as Vs upon 1 minus delta. Now for the, this is for continuous conduction. Whereas for the discontinuous conduction, Vs upon 1 minus delta will be replaced by delta by beta. So similarly, if you write the buck boost converter, continuous conduction, delta into Vs upon 1 minus delta equal to delta will be replaced by delta by beta in case of discontinuous conduction, delta by beta into Vs upon 1 minus delta by beta. You can also simplify it further. It can be written as delta by beta upon beta minus delta by delta into Vs. So you can simplify it further. Sorry, it is beta, right? So beta will get further cancelled out. It can be written as delta upon beta minus delta into Vs. So this is how we are writing the voltage expressions for the discontinuous conduction. The same way, kindly just revise all other formulas, critical inductance, and then minimum inductor current, maximum inductor current when inductor is charging from minimum value to maximum value. We know I told you this minimum value will not be 0 when we have the continuous conduction. So they will just we should focus, right? In the lecture I just simply taught you how to calculate the average current, what is the relation between IL average and output average, and how to obtain this maximum current, how to obtain this minimum current. Everything is available in our lecture. So learn everything in a proper way, step by step. That's this all things are very important. And this circuit is very easy circuit. Chopper circuits basically are very easy circuit. See, power electronic itself, it is very easy only. I told these things many times. It is very easy only. But the only thing is we should understand how to develop the equations, how to solve the questions in a given sequence. Okay, so this is all about copper circuits. So we were completed almost what are the things that are required. I had given some basic ideas. I hope it will be useful for you all. What you have to do is, before coming to the next class, just keep your attention with the two parts. What are all those two parts? The thing is, first learn about, you must learn about inverters. Basically, in inverters, first keep your attention with the single phase, then keep your attention with the three phase. In single phase, once again keep your attention with the voltage source inverter, and then keep your attention with just have a look about current source inverter also. Similarly, in three phase inverter, what will happen with the 180-degree mode of conduction and 120-degree mode of conduction? What is the basic difference between these two, and which one is most preferable one? Just look into this. After that, just immediately enter into pulse width modulation technique. Don't go through all things deeply. Just basically learn classification of pulse width modulation technique. What is the generalized formula for the single phase circuit in case of pulse width modulation technique? How to write down the generalized expression V naught of T. So you have to learn some basics about pulse width modulation technique also. This is the last part of our power electronic circuit. So just have some patience, learn all these basics, then try to come to the next class. So this is all for this lecture. Remaining things we will see in the next class. Thank you all.